Good morning. I hope you're doing well. As you can probably imagine, I am doing quite well myself. I think it's probably worth starting off with a demo. Very first thing, demo today. I'm a little bit nervous about this because the reliability of what I'm about to show you is not fantastic, but it works most of the time. So let's see. So we can boot Jugglebot up. Go through the usual homing sequence. Auto-calibrate the platform to make it so it's flat. Bump. We can do our little practice throw, or first prime the hand. Good to see you, Dean. Nice, nice and clean. All right. Now I've got to get in position for this because I'll talk about this a bit in a sec, but I have not done what I said I would do last week regarding me priming the hand. And it's taken a bit of practice for me to be able to do this, but I can do it most of the time. But sometimes, yeah, sometimes that happens. So let's just wait for that to finish. So what just happened then is what it's supposed to do is it's supposed to move over to, it's like it starts off in the middle, it's supposed to move over to the side, wait until it's stopped moving, and then throw. Probably like 1/3 of the time, it doesn't do that and it just moves while throwing. I have a feeling I know why this is happening, but I haven't been bothered to go into the code and fix it yet, and so whenever that happens, I just wait for it to finish and then run it again. So let's see. Oh, so close. Oh, it's really strange how sometimes the presence, so like if I just run this with one ball, okay, most of the time that works properly and won't drop, but often it will like run a bunch of times in a row working with the one ball, but then as soon as I add the second ball, the first ball stuffs up as well. It's very bizarre. Some strange things are happening, but sometimes the stars align and it works perfectly. That was a bad priming on my part. I don't have a whole lot of time to get the ball into the hand here. That was good. Ah! All right, let's try a couple more times, and then I've got some recordings of this to show you, which are a bit more reliable. Oh, and as you'll see in the recordings, there's a lot of, everything has to work very, very nicely for this to behave. There we go. Just a little nick. Ooh. I always forget to catch that last one. All right, one more try. Let's try, actually, no, let's just try the same. Ah, no. All right, I reckon we'll give this another go in a bit, but I want to show you some other things first. Some recordings, which are, of course, a lot more reliable because they actually happened and I know that they worked. But even though this is super unreliable, I don't really mind because this is really all that I've wanted it to get to. This, I feel, is enough to make a proper, like, I feel this is good enough to call this being 2 balls in 1 hand juggling. Maybe not, technically I think that just was then, but definitely some of the runs that Jugglebot's gotten where it's done like 10 to 15 catches cleanly, that's definitely like pretty hard to argue that that's not juggling. And I think this is extremely exciting because as far as I can tell, this is actually the world record for robotic 2-ball juggling. There's a handful of videos that I could find of robots doing 2-ball juggling. Most of them are with like little like ping pong balls or little metal balls that bounce really well. And I don't count that as juggling. That's not the same as what Jugglebot is doing here, where it's actually catching the ball, holding it for some amount of time, and then throwing it up again, rather than just like instant contact, bouncing it up. So I don't think bouncing counts, in my opinion. I'm a little bit biased, but that's what it is. But there is this one video of an actual robot. Let me go to the start. An actual robot doing 2-ball in 1 hand. You see 1, 2, 3, 4, 5, 5 catches. As far as I can tell, this is the most that any previous robot has ever gotten. So Jugglebot doing 10 to 15. I believe 15 is still the record for Jugglebot. Blows this out of the water, no question. Jugglebot is the best juggling robot in the world right now. Granted, the video that I just showed was from 12 years ago. So if the people who were developing that continue to develop it, then there's a good chance that they could have easily beaten Jugglebot as it is right now. But as far as I can tell, they didn't, and they stopped. So I think Jugglebot is the best robot to ever juggle 2 balls, which is very exciting. Yes, brought to you by Dean says, it's like it's starting to move laterally a microsecond before it finishes its vertical stroke. Yes, inducing a slight arc in the path. Yes. There's lots of problems with this. So let's have a look at some recordings, because these are very, very interesting, in my opinion. So, I don't know why that hides things sometimes. So we've got a lot of things there's a lot of strangeness happening here. One thing is this. I had a really good, here. So what I did here is let me get rid of me. I have taken one single frame from there, and that's now opaque behind, or like translucent behind the background. So we can see exactly what's happening between that first throw here and what happens next. And we can see the ball goes up. It looks like it's fairly straight, but then when we come back down, we can see that it is actually, also I know that this is probably worth mentioning here, these 2 camera shots, these 2 here, I have done a fair bit of work to make these in sync, and they are now, but they are out of sync with my other camera. But I believe in a lot of these recordings I'm about to show you, they're actually slightly out of sync, which is a little bit annoying, I know, but it's a pain in the ass to fix in the video. I can do it in the video editing software, but I did a lot of this stuff very recently, so I haven't had time to fix that timing up. So some of these shots will be out of sync between the 2 cameras. It's annoying, I agree. Yeah, so we can see as we continue, that ball lands just to the side of where it was before. So we can see, if I move this around a little bit, you can see that's just, I'm looking particularly at the video on the right. I don't know if I can actually zoom this in. Yeah, here we go. Oops. Can I full screen now? Oops. I'm a little bit out of practice in my video editing. It's been a little while. Let's hide this stuff. Okay, cool. And let's go to here. Yep, nice. Cool, so we can see we throw up. Second ball comes down, that's all fine. First ball comes down slightly to the side of where it was. And we can see the platform lines up pretty well. The platform where it was before and the platform where it is now, this frame is that's perfectly lined up. It does continue to move a little bit too far, and we can see there's a bit of a wobble in the settling time here as I move this back and forth. You can see that takes a second to kind of land. Here is exactly where it was when it threw, and then it continues. This is playing forwards, it wobbles, and then finally arrives back at where it was. But the ball is not exactly where it was. It is slightly to the right of where it was. And this is a problem, obviously. And as we continue forward, we can see that actually, sorry, I've lost where I am. So this is the first throw, up, catches slightly to the side, and let's see when we move forward again. Still, yeah, when it's throwing, it's in the exact same spot. So that is good. Everything there looks perfectly lined up to my eye. Granted, this is only 60 frames per second, so it's a little bit tricky to see what's actually going on here. More on that in the future. But yeah, that looks perfect for me. But again, as we continue forward, second ball comes down, that's all good. First ball comes down, even further to the right of what it was before. Not good at all. Now, Brought to You by Dean has suggested that potentially it looks like, it's obviously hard to tell in real time, but he was saying it looks like the platform is imparting a little bit of sideways push to the ball just before it's getting released. I actually don't think that's happening. Oh, God, that's annoying. One of my hotkeys for the thing that I'm using to control the camera is interfering with DaVinci Resolve and is hiding my videos. That's what that is. That's a bit annoying. But at least I know what the problem is now. Yeah, so we can see the ball leaves the hand before the platform even starts moving at all. So the ball is gone, and now, only now does the platform actually start moving. I've got a lot to say about this, but yeah, I don't think the platform is imparting any, I don't think that the platform is imparting any sideways motion to the ball in the way that I've currently got it set up. I think what's happening is that the platform is not perfectly straight. I think it's just on a very, very slight angle, and that's causing this ball to move just a little bit. I could and probably should, if I had more time I would, but yeah, I could potentially figure out how, like I know the size of the ball fairly well. I mean, these balls, to answer Michael's question, these balls, I know, brought to you by Deans, they are special juggling balls. They're filled with some kind of like pellet. I don't actually know what it is, but they're fairly squishy, not super squishy, but like once you squish them down a little bit, like it's firm after that point. So I don't know what you would call these. Incidentally, while we're on the topic of balls, I actually have bought a whole bunch of balls. So now I have like tons in different types. I've got these like really super hacky-sacky ones, as well as these ones that are called like thud balls, I guess because they don't really bounce much. But interestingly, these ones have actually performed the best. I haven't spent a huge amount of time testing this, but I gave each ball type what I felt was like an honest run, and for whatever reason, these ones do the best. I don't know exactly why, but they do. Obviously, this is extremely sensitive to everything, so it could just be like a wild fluke that these balls are the best with the setup that I've got right now, but that's the way it is. Yeah, so I could figure out, so I know the size of these balls, so I could figure out, okay, it's like, we know how big the ball is, and we can see that it is landing just, let's go forward just a little bit here. We can see how far it's landing to the side, and then we can calculate what that release angle would have been to lead to that like offsetting position, potentially. Oh, whoops, oh crap, I was on the wrong camera, sorry. Yeah, so we can see that it's slightly off, and we could figure out like how far to the side that is and what angle the ball was thrown at to lead to that change. Yeah, could definitely do that. Just before the stream today, I actually went through and found what angles the platform is actually at. So if you've been following along, you may remember that we've got a sensor on the back of the platform that can detect, can measure angle with respect to gravity really precisely. And I went through and moved the platform to the throwing positions in these two column positions, and it is pretty much zero. I need to do a little bit more looking into this, but it's as zeroed as the default straight up position. And in that default straight up position, it can throw and catch perfectly, cleanly. It's like beautiful. Actually, I want to show you this because this is kind of cool. That's weird that the camera just turned off for a second then. Those are juggle balls that are weighted right. There's a filling that's shifting within the ball. Yeah, so that's one thing that I am under the impression that this system is quite sensitive to, is the shape of the ball when I put it into the hand. As crazy as that sounds, I think that does actually make a difference. Like whether it's, like this is the old hand, so this is a lot smaller than the current hand is, but if I put it in like here versus here versus here versus like that tiny little bit of difference in position, I think is affecting things here. Not certain, but I think so. Check out rubber sand-filled stress squeeze balls. Interesting. That sounds similar to a type of juggling ball that people tend to use, and you're right, I should pick some of those up. That's a good suggestion. I'll get some. Michael asks, do you plan to add some sort of camera or sensor for adjusting small trajectory changes? I definitely plan to be adding eyes of some sort so that Jugglebot can actually see the balls and get feedback from where the balls actually are. That is probably the only point of contention that I could see people potentially having with whether or not this is actually a juggling robot, because this is all open loop. Like Jugglebot has, I mean, you could see that when it stuffs up and it drops, it has no idea, it just keeps going. So in that regard, maybe it's not technically a robot, but I definitely do intend to add those eyes at some point, but for now I just wanted to get like a proof of concept that it works at all. But yeah, so what I wanted to show you is that when Jugglebot throws in its default, just straight up position, it's very accurate and very clean, super nice. Let me move me over here. Also, I've been playing around a little bit with the camera views here. Do you guys, I think this is nicer because the two shots are like right next to each other versus like before I had them sort of like this. I don't know. Any feedback is very appreciated. But yeah, so we can home. And auto align. As I've said so many times, I really need to make this automatic on startup. But I haven't gotten around to it yet. And we can do a practice throw. We first prime the hand. Again, I need to do that automatically. Yeah, so that's clean, that's super clean. And I've done a thing. So what I want to have happen, when we're doing two balls, what ideally should be happening is it will throw the first ball, move over, catch, throw immediately, to give as much time as possible to move over to the first spot, catch, throw, move, catch, throw, move, catch, throw. So it's like catching and throwing instantly. And so what I wanted to check is like, is this actually possible, or do we need some amount of settling time for the ball to like land in the hand properly and kind of like get settled before it throws? Because there are quite a few times where the ball like rims on the edge of the hand, and it looks to my eye like the ball, if it has time to settle in, then it will sometimes settle in and then throw properly. But my question was like, is this actually necessary? Do we need to do this? So I made a throw continuous function that will, as the name suggests, throw continuously. And that works perfectly. Like, that's so good. So clean. So clean. For anyone really, really following along, John in particular, I have actually changed the what is it called? The linear gain factor. So we have on the back of the hand is a spool, and around that spool is wound a string. That string goes up, and that's what's actually moving the hand up and down. We need to have a very, very accurate mapping of how big that spool is so that we know exactly like one revolution of the motor will move the hand by exactly this amount. And I have actually had to change that down a little bit. So right now this is 0.96. If I have this as 1.0, so the hand is moving as far as it thinks it should be moving, and we can see the catches are not nearly as smooth. Yeah, see that dropped then. Yeah, so just that 0.04 difference is enough to make the catches silky smooth or not smooth at all. I have adjusted that for the columns throwing, so that's all good. But yeah, so that throwing and catching like instantly works, but that's not what it's doing when I'm doing two balls in one hand. So let me show you back to the videos. Nice, thank you Michael and James and Dean. So let's go, where do I want to go to? Actually, I think this shot works. Need my different mouse. Oh, we're hidden. Cool. So, yeah, we can see what's happening. Let me go back to here. We can see that what's happening is the ball is being thrown. Let me go back when there's actually two. Let me cut ahead a bit so that we get rid of that second view. So we can see the ball is throwing, it's moving over while the hand is moving down. This is so tight. And we can see, of course, because the ball's landing to the right of where it should be landing, that, oh, I'm going to cover that. I'll put me over here. Oh, this is so confusing. I'll put me over here. There we go. Yeah, so we can see because the ball is landing to the right of where it should be landing, sometimes, like in this case, it has hit the side of the hand and that looks, yeah, non-recoverable. But even as it is, that timing is all wrong. It's throwing and then it's trying to catch as, it's trying to move over as it's catching the, whatever, first or second ball. Same thing here. It's moving down as it's moving across. This is not what I want to have happen. I do have, I believe, a clip after I fixed this. Let's see. Maybe this isn't it. Yeah, actually no, this is it. All right. Yeah. So let's skip ahead a bit. So we throw. Yeah, this one you can see my hand is in the way a little bit. You can see it moves over and then goes down, and then throws and then moves over and then goes down. But interestingly, when I made this change so that the platform moves and then the hand goes down and then it moves and then the hand goes down, as soon as I did that, it introduced an asymmetry here. So if I play this back in real time, you can see the platform spends the overwhelming majority of the time in the right position from our view. So it will it will move over and then it will like, go here, move, 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 move. I don't know why this is happening. This is extremely similar to the problem that I was having before when I was mucking around with timing. This is definitely something to do with the way that I've coded this up. My code is definitely needing some improvement. So this all raises, actually let me check comments first. Is that gain going to become a parameter that gets adjusted when there's a closed loop feedback? Yes, but hopefully we won't need it. So hopefully, well, yeah, potentially. We could set the robot up so that when it is throwing let me show you one thing first before we get into this. There's a lot of things to talk about here, but one cool thing is that I noticed that the ball is actually not throwing to the same height every single time. So here it is. So what I've done here is I've added a green line onto the top of this first throw here. Boom, right there. It like just kisses that line on the top of that throw. I believe there is a little bit of parallax error with the way that this camera is set up. It's not perfectly perpendicular to where Jugglebot is, so we can ignore this second throw with respect to that line. I mean, anyway, it's pretty much bang on. But particularly for this first throw, for the ball on the right, we can see that time, that's pretty much spot on. That hits pretty close. That one was a little bit low. Just a smidge, but definitely low. This one, that was pretty much perfect. So it's close, but it's not spot on. That one, that's too high. That's maybe not way too high, but that's definitely over the line. This might be a little bit hard to see. Let's do it like this. That should be nice and easy to see. So that's way over the line. Next one, we just can't see if it's actually going or not. Okay, I think we're on the next run. And here, this is so much lower. Oh, actually, that's pretty close. But the point is, it's not perfectly consistent. Look at that. Where was it? That's so low. That's so low. So it's not throwing perfectly to the same height every single time. And this is consistent with the data that we're getting back from the hand, which I was under the impression was a little bit affected by the sampling rate of our of the hands. So let's see, I've got a thing here that will plot the most recent run. So this is the run that we just did just a second ago, where I was doing the throw continuous. And we can see, these ones are spot on. I've moved my files around. Let's do another run. Let's do another two in one hand run, and then we'll collect some data so I can show you. In the meantime, while I'm booting this up, let me answer some reply to comments. Yeah, multiple panel seams sewn together. The seams can introduce variables. Yeah, it feels like they shouldn't, but I think you're right. I do think you're right. Mimicking motion with single-handed juggling. As a juggler, there's a reason we start with both balls in the same hand at the start. Okay, yeah. So this gets to multiplexing, which is a thing in juggling where you can throw two balls from one hand at the same time. So you can like stack them vertically like that, or you can throw them so that they go to like the same height like this and like split them between the hands. This is very cool. I don't think Jugglebot will ever be able to, well, I don't expect for Jugglebot to ever be able to do this. Any version of Jugglebot that I make, at least. Definitely possible in theory, if you're keen enough. But holding multiple balls in one hand and releasing them one at a time is okay if you're doing just two balls, but where do you stop for that? Like, how far are you going to go? I am planning for Jugglebot to be able to do 14 balls between two hands, or really just like 7 balls in one hand. There is no way we're going to be able to make a system that can hold 7 balls in one hand, release them carefully, one at a time, each in a reliable, repeatable way. That's not going to happen. So I am very much leaning towards a launcher or some sort of like primer that will add additional balls into the system when we're doing multi-ball juggling. Right now, I am that primer. I don't really like that. It's very stressful sitting there. There are so many shots of me like almost getting the ball in the hand and having it just like fly out to the side, or just like completely getting the timing wrong and like putting the ball in as the hand is like rocketing up. It's so hard to do. Luke Burridge had a very good suggestion recently from the last stream to have a dropper in from above that will just drop the ball down. I like that idea for the development phase, but I'm thinking for like long term, I really like the idea of a little launcher that can sit down beside Jugglebot and just like pop the balls in. I think that's a really clean long-term solution, but definitely in the short term, I really do like this dropping idea. I think that I'm very confident that I'll do that before the launcher. It just means that it's going to be harder to put the balls into that because I'm going to have to like reach up and load them in. Yeah. Your platform is like trying to juggle without fingers. Yeah, juggling with a cupped static hand will be so difficult. Yes, there is a thing called kendama juggling where you just have kendamas in your hand. If you don't, they're like that Japanese, I think it's Japanese toy with like the two, it's like a hammer sort of shape with the two cups on the side, and you can like, and there's balls on a string, and you can like get the ball in the hole on the end, or like bounce it in the cups. There's like one guy who can juggle really well with kendamas, well, really well. But yes, it is extremely difficult, extremely difficult. Are the balls identical weight? Pretty much, yeah. I don't know if I'm right, Michael says, I don't know if I'm right, but I see a little bit of oscillation when the robot tries to stop. Yes, on either horizontal positions. Yes, definitely. There is a good amount of settling time, as I've been calling it. I really need to fix these hotkeys so that they stop hiding everything. But yeah, we can see, let's go to here. Where are we? I have 3 keyboards in front of me to do all this. This is nuts. There's definitely a good amount of settling time. Like that wobble, that's no good. No good at all. Look at all that. That's going all over the place. That is, I'm fairly confident that that is because there is a fair bit of slop in the joints between the legs and the platform. I actually might even be able to show you. Let's zoom in. Whoa, this is so hard to control. No. Go back. Go back. There we go. Oh my God. This here, I don't know if that's, yeah, I think you can see that. That slop is no good. This was raised a couple of weeks ago, and I'm very aware that it's a problem. I'm fairly certain I know where the problem is. I just need to fix it, but I haven't had time. So I'm not too worried about that right now, to be honest. I have an idea of what that is, and yeah, I think once I fix it, that should be fine. What I understand the problem to be there is there are bearings in the printed part in here, and as far as I can tell, those bearings are not seated perfectly in their like cutout spot in the 3D printed part. I don't know if this has become worse over time. I can only suspect that it has, but those bearings can like move a little bit in their little hole, and that's causing all of this slop. And so my plan, I bought some JB Weld. My plan is to just glue them in so that they can't go anywhere, which should hopefully fix it. Michael says, did you tweak PID values to adjust for it, or algorithm compensating for this? I'm assuming you're talking about the wobbling there. There is actually no PID in Jugglebot at all, except, no, there's no PID that there's no PID for like the whole robot. There are for the individual legs and for the hand, but nothing for the entire system. And yeah, there are, however, I can change how quickly the legs can move, and that has made a big difference. Originally they were way too slow and they just weren't arriving in time. If I have those like velocities and accelerations to be too high, then I've actually had one of the legs got like ripped out of its base joint, because in the base down here are just magnetic joints, and they're quite strong. Like I can't pull them apart by hand, but the momentum of the platform moving to the side and stopping was enough to rip that magnet out. So yes, if I have those too high, then everything falls apart. What I've got right now seems to be a sweet spot where it doesn't kill itself and it's fast enough to still move. However, actually there's one other thing that I want to show you before we collect more data, which is just how close this all is. Like, it's insane. There's no chance I could juggle 2 ball columns as tight as what Jugglebot's doing. So let me show you. There is a clip that I've got at the very end of a perfect, I think it was 10 catches. Oh, why do you hide it? Stop it. Oh no. Yep. Oh, that is correct. Oh, this is so confusing. Yeah, so you can see this. Actually, I'll play it in real time first, and then we can watch it back. So this is so clean. Look at that. But you may have noticed just how close together those balls go. Look at that. Ooh, ooh. They are like millimeters apart. It is whack that this works. On like every single one as well. It's like so close. They just like kiss each other. Ooh. So tight. For reference, I have set the distance between the 2 throws to be 10 centimeters, which is one ball being here, and the other one's in the hand right now, but the other ball is there. So they should be about that far apart. But of course, because as far as I can tell, I think the platform is tilted a little bit, so they're going slightly in. That is something that I have changed so that I can adjust that. But of course, the wider apart I make those, the further the platform has to move. And given that the platform is moving while catching, that's a bit of a sketchy proposition. So it's all very, very fine balance. It's a bit of a miracle that this works, to be honest. And it's a very big miracle that I happened to stumble upon the perfect combination of things that worked. Because I've tried improving on what I got on like the very first couple attempts, and those improvements have only ever made things worse. So it's like, it just so happened that what I tried at the beginning was like pretty close to the optimum functioning program for the way the Jugglebot's set up right now. Oh my goodness, Michael, go to sleep. Thank you. All right, so let's get some more data, and I want to show you the telemetry data of the 2 in 1 hand. So we have not even booted on. And then I'll reply to some more comments. I'm getting warm. It's time for dressing it up. It's starting to warm up now in Melbourne, and I'm liking it a lot. It's fewer and fewer dressing gown days every day. All right, so it's home. Why did the hand not home? I'm just going to run the homing again. Sometimes things are a bit weird. There we go. That worked. So we can align, prime the hand, and then practice throw. Nice and clean. All right, so now we can try 2 in 1 hand, and I'll show you what this data looks like. I've also tried, actually, one thing before we do this, I've tried, last week I mentioned that to give me the most amount of time to put the second ball in the hand, What I wanted to try was throwing the first ball a little bit higher and then moving the hand over, keeping it at the top, and then moving the hand down as slowly as we possibly can before then throwing. I didn't actually end up trying that at all, because what I tried instead was just to get the hand to move down as quickly as it possibly can. So it throws and then instantly moves back down, and just hope that that gives me enough time. And it turns out that it does. Just. Very, very just. I have, however, I've made something that will throw the first, I've set it up so that it will throw the first ball slightly higher than the second ball, or like all subsequent balls. And that does give me a little bit more time, but I think that if I make the difference too big, then the rest of the timing of the rest of the pattern mucks up, purely as a result of the sketchiness of my code. It should be possible to do that, where it will like throw the first ball super high and then drop into like consistent 2 columns, but my code is not good. Not good. So let's see if this will work. And let's see if it actually moves over before throwing. No. And I really do need a way for it to know when it has dropped a ball, because it's very annoying having to wait. See, they're slightly too close. But only sometimes. Sometimes it works perfectly. Let's try one more time, and then, okay. That just hit the end stop for some reason. That's one thing that I need to look at a bit more as well. So that should be enough anyway. That'll have given us the data we need. So we can shut down. And let me clear these errors. Turn it off, turn off that fan, and then go to here. Okay, so this is the data from that run that we just did. And we can see, I mean, look at these velocities, the first up. So the first throw, keep in mind, is a little bit higher. So that first throw is fine to be higher. But look at the inconsistency of this. So I previously was under the impression that this could potentially be a sampling rate problem, where because this is only being sampled at 500 hertz, it's possible that we're missing like the perfect peak of all of these spikes. But now I'm not so sure, because we can see in the recorded footage the ball doesn't always go to the same perfect height. I think there's something going on here that's making the hand not throw quite as fast every single time. It's not perfectly reliable. Yeah, so I'm still not convinced that this isn't a sampling rate issue, because like these data points in particular, like that looks a lot like just a single data point. Like that really, for the velocity at least, the red one down the bottom, that screams single data point to me. So it's entirely possible that the actual peak was like down here and it just hasn't picked it up. Yeah, so it would be good to be able to increase this monitoring rate to like 1,000 hertz or even like 1,500 hertz, just like go crazy. But I don't know if the CAN bus will support this. So many things to try. Let me look at some comments. James says, instead of adjusting it until it's perfect, engineer the right sensor feedback so it can self-moderate. That will let it become much less rigid, and it's, yes, definitely, absolutely. I actually am very convinced that an AI-controlled Jugglebot will blow my whole control system out of the water. I have very few doubts on this. It's just a matter of how to actually create that AI. I think there'll be a point in the next year, probably, where I have a very difficult decision to make as to whether or not I spend time continuing to refine my hand-coded control system, or do I start working on an AI one? Because I expect the AI one will probably take a while to like get set up in the first place, but I expect that once it's working, it'll be so much more accurate. Especially if I can get motion capture cameras in this room, if I can give that feedback at like a couple hundred hertz of like the exact position of everything, including the balls, if I can just give that to an AI and say, hey, this is where everything is, you're in control, good luck, I think that has a very good chance of working if the AI is good. Which, I mean, NVIDIA has done a lot of work to make good robot, like physics sims to do exactly this. And that's only getting better. So I feel pretty good about that at some point in the next couple of years. Josh is saying, have you considered a hand design that actually closes around the ball as it catches? Absolutely. We've been referring to this as grasping. So this will be like a grasping catch versus a, I don't know, current just cupping catch. Definitely grasping would be better, but it's hard to do that. It's definitely a lot easier said than done. One possible idea, which is like semi-grasping, would be to have some sort of like camming mechanism where the, let me draw it. Let's go to here. Jugglebot can juggle. Yeah, so ignore the title. But right now the hand is like this, and it travels on this rail, and that's the only thing there to catch the ball. But one potential option would be to have like walls that are here constantly. They're like static walls. These move with the platform, but they don't move with the hand. And then having like an elevated bit up the top, like a giant big funnel up the top, so that, let me put me back. So that when the ball goes, and these like funnel arm things would be able to rotate, and they will be in sync with the hand moving, so that when the ball is coming in, these arms are nice and wide, but then as soon as the ball has landed, these arms from like some sort of mechanical system would get hit by the hand on the way down, and that would cause them to close up. And then we would have this nice tight channel for the ball to stay in, and that would make it very hard for the ball to move around. This is not quite grasping, but if we can get these walls close enough to the hand, which I don't see why we wouldn't be able to, then this will be pretty close to grasping, because the ball won't be able to move side to side at all, or like front and back. I think this is the most promising version of a semi-grasping hand for this version of Jugglebot. Everything else is just so complicated. Like, we want the hand to be as light as we possibly can, because that's moving around so fast, and it's only being controlled by this little tiny motor. Like, these motors are so small. So we want this to be as light as we possibly can make it, and we want it to be as not complicated, as simple as we want it to be as simple as it possibly can be, because any added complexity is just more stuff to break, especially when these things are moving really quickly. Yeah. I'm very not keen on the idea of running any cables to the hand either, just because of how quickly this moves and how much stuff there is there to catch cables. I'm not very keen on the idea of having cables run to the hand, which makes some options a lot more difficult. Yeah, so definitely have considered it, but it's quite tricky to do for this version of Jugglebot. I think future versions of Jugglebot will be much more amenable to having a grasping hand, but we'll have to see what they look like. Yeah. Yes, so I want Jugglebot to be throwing immediately after it's catching, and it's not doing that. And I don't really know what in my code is causing this to happen. So one thing that I've done is, I mentioned last week that I want to have the governing timer of this whole system being the beat. And one beat is the difference in time between one throw and the next throw. And for some reason, when I shorten the duration of this beat below the minimum duration of the beat that I calculated, for some reason, that gives the platform more time to move, and it does what I'm trying to do, but that leads to this asymmetry that I showed before, where the platform spends most of its time over here, and then it goes da-da, da-da, da-da. So my code is cooked. My code is cooked. Really, what I want to have happen is there are graphs that look like this, where you can display the hand's perspective and the ball's perspective, and you can do this for all of the hands and all the balls, and you can get this nice, like, these bars showing what everything's doing at each time. So I actually don't remember where I got this from. This was like a couple of years ago when I first found this, but we can see, like, this is just one ball, and this is doing 3 ball juggling. So we can only see here one hand and one ball, so there's a little bit missing, but you can see, like, when it's holding the first ball is being held, right? That makes sense. And then we throw the first ball. The first ball is thrown. The first ball is now in the air, and the first hand is empty. But it's only empty for a short period of time before it then catches the second ball. And during this whole time, the first ball is still in the air, and then eventually it gets caught by the other hand. Meanwhile, the first hand is empty and then catches the third ball. And then finally, after all of this, it syncs up again, and then we start the process again. So we can construct a diagram similar to this for 2 balls in one hand. And I haven't completed the whole thing, but hopefully you can mostly get the idea. And you can see here, I've got a beat, is the time between one throw and the next throw. And what I really want to do here, what I'm trying to do, is to give the platform as much time as possible to move and as little time as possible to catch and throw. Because we've seen that it doesn't need extra time. It doesn't need time for the ball to settle if the throw is accurate, which is a whole other thing. But if the throw is accurate, then it can just go catch throw instantly. So we can afford to have this blue, all of these blue strips be shortened to allow the green strips to be lengthened. My diagram here is a little bit misleading because I've drawn the blue and the green to be very, very similar lengths. These don't need to be the same lengths. They can be shifted a little bit with respect to each other. Obviously, you need to hold the ball for some amount of time because, I mean, I guess if you're bouncing it off, then that would be like the asymptote of how small you can get that. But for what I want Jugglebot to do, I don't want bouncing. I want like proper catching and the throwing. So that blue portion has to be some duration, but that only needs to be like 0.3 seconds. And that will give us a lot more time in this green section to allow the platform to move. Now, the reason why I bring all this up is because I really, really want to make a system. I think that this is like very high on my priorities list right now. I probably won't get to it until I'm back from holidays, but I almost certainly won't. But hang on, sorry, I need to cough. So good. Yeah, what I really want to do is make probably a ROS node that will take in all of the parameters that I've put in for whatever juggling sequence we're doing, and then construct this graph out of those parameters. So we can see exactly how much time is being allocated to all the different parts, and we can see where things are lining up and where they might not be lining up. I think this would help tremendously with getting the timing right for all future patterns. I suspect that if I were to plot this graph with the current setup that I've got right now, especially once I try shortening that beat duration, which again does allow the platform more time to move, but for some reason leads to this asymmetry. I am pretty confident that if I plotted this graph with my current setup, we would see immediately what the problem was. So that'll be good, but of course that takes time. Yeah. There's lots and lots of stuff to do, but it works. Cool. And yeah, so we can see the balls aren't thrown vertically or to the same height. Big problem, big problem. Also, yes, this is the last stream until October 4th. Once I got this working to a reasonable capacity, I tried a little bit more to get the timing just right, but honestly, I have not actually beaten the record that I got before of 15 catches. So 15 catches is the standing, as far as I can tell, as far as I remember, 15 catches is the standing record for Jugglebot right now, which to be honest, I'm pretty happy with. I am going to continue running this to get some more footage for the next video, but I'm not going to spend any more time trying to tweak the tuning or anything. I've spent quite a while on that already, and I think a big overhaul, making this sort of like charting that graph that I just showed you before. There's a lot of stuff that I need to do to actually do this properly. And yeah, I don't need it to be working properly right now. I just need it to work enough for one video, because I am now fully committed to making an update video. It's been a very long time. I actually checked when my last proper video was made, and it will be almost exactly, it'll be like 4 or 5 days off of 1 year between my last video and this video that I'm making now. So I think it's definitely time to make this update. I'm really, really hoping I can get it done before I leave. I'm leaving in 2 weeks from yesterday, so I now have 13 days to get this done. And really, I probably don't want it to be published on like the day that I leave, just in case anything goes wrong. So yeah, not a huge amount of time, but I feel like I should be able to get something done. I'm really hoping as well that I can, if I can get this done, I'm planning to publish this video as a premiere, which will be very exciting. Which means that when it goes up live, when the video goes up, there will be a sort of live stream interface where I won't have any camera or anything, but I'll be on the chat. So it'll be like it'll be a chat similar to what we have right now, but I'll be like there to comment on stuff, which will be pretty fun, I think. I'm keen for that. I think I'll probably do it at a time that is more appropriate for my US viewers, which this time right now is very much not, which is a bit unfortunate, but there's no way I'm doing these live streams at like 2 a.m, so not happening. But I can do that for one premiere video, I think. I think it'll be fun. Yeah, so lots of stuff going on. It actually works. It's amazing. We've done 3. Let me show you my banner. I'm very excited about my banner. It's finally like looking good. I feel like right at the beginning when I only had, when I had like the first goal ticked off, it was a bit like, it's not the best, you know? But now it's actually looking nice. Look at this. 3 goals ticked off. We're halfway there. Halfway to beating the world record. It's that easy. Yep. Of course, these last 3 are significantly harder than the first 3, but, you know, got to start somewhere. It's getting there. It's getting there. Cool. Okay. I think I've addressed everything. It's definitely lots to do. Definitely lots to do, but it works. And for that, I'm very, very excited. If also, because I'm still in the early stages of planning this video out, if anyone has any suggestions for what they would like to see in the video, let me know. I'm definitely open to ideas. I haven't started recording much yet, but I think it should be good. I'm keen for it. Which Doctor says, thank you for bringing us along with this. That double juggle a few minutes ago was awesome. US viewer, good to view. Good video to prepare dinner to. Very nice. I hope your dinner's looking and smelling very nice. Yeah. I really hope that, well, I know that at some point Jugglebot will be able to do 2 wall columns indefinitely, continuously, and it'll be beautiful. That day will come. It's not today, but it works. It works a little bit, and that's exciting. That's all I need for a video. Okay, cool. Hope you found that interesting. And yeah, I'll see you in 5 weeks. I'm considering as well, one other thing. I'm considering doing a live stream after the premiere of the next video. So this is something that YouTube allows you to do where you can like, as soon as the premiere ends, so like the video has run its 15 or 20 minutes, whatever it is, it ends, you can set it to like automatically feed people into another thing, like another video or a live stream. And I'm considering doing a live stream afterwards. It would probably be largely similar to what we just did here, depending on how much I can tweak things. I know that I said that I wouldn't tweak things, but I might, just a little bit. But yeah, I'm unsure. Open to suggestions. All right, cool. I'm rambling. I hope you found this interesting. I hope you enjoy the rest of your day or evening, as the case may be. Good luck with everything you're doing, and I will see you probably in, I think, 5 weeks. Yeah, till then, goodbye. And hopefully, fingers crossed, you'll see a video from me sometime in the next 2 weeks. Big fingers crossed.